Okay, it's being recorded now. As usual, any questions, please stop me if I'm going too fast, but I will record them and I'll post on Google Classroom. The first 3 slides are review from our Monday lecture. I think Monday or Tuesday, I don't remember what the lecture was. The first one was Limasson with inner loop. And I will just quickly go over the graph of it. I'm not going to demonstrate Desmos anymore. I did it last time. But for this one, it's sine, and it's negative sine, which means it will be below the x-axis. And as usual, whenever I will draw or sketch it, I will first of all visualize it. All right, so Limasson looks like something like that. So that's what I'm trying to draw. My y-axis, my x-axis over here. Okay, I would like to go 3 plus 6. I'll go 9 units down. I will then go 3 units to the left, 3 units to the right. And this will be my x-intercept. And to find out the y-intercept, I'll do 6 minus 3, and it's at 3. 1, 2, 3, right here. That will be the y-intercept, or when the inner loop is located. And just sketch it. I prefer to start with the inner loop, and then you go through these points. And here you go. Pretty beautiful graph of a pretty complicated equation. I'm pausing here for a bit, waiting for your questions, concerns, suggestions. All right, next one, cardioid, my favorite shape. Cardioid happens when these numbers are the same. Basically, it will be same as Limasson with inner loop, but without the loop. And that's called cardioid. Was there a question? All right, I thought someone said something. All right, but how to draw cardioid? It's pretty much the same approach. Because it's negative sine, it will be located below the y-axis. I'm going to go 12 units down because it's 6 plus 6. I'm going to go 6 to the left, 6 to the right, and draw something which looks like a heart. And that's called cardioid.
Miss?
Yeah?
Michael's trying to join the meeting. Says that you need to let him in.
Who is in the meeting? What is it?
Michael is trying to join the meeting, but it's not letting him in.
I don't see him in the waiting room. I can just try to reshare the invitation link with him. I'll just email it to him, but thank you so much for telling me. Hold on 1 second, I'm just sending an email to Michael since he desperately is trying to join pre-calculus and he should not be missing such an important information in his life. No, I can't. For some reason, my email is frozen. I tried. I know. No, I couldn't send it to him. I don't have his email. Sorry, guys. Can anyone send him the link? I think I shared on Google Classroom, and since you guys joined, I think it's a problem on his side then. Oh no, Michael is here. Hi.
Yeah.
All right. I'm glad you're here. And we are on the third shape called Dimpled Limasson, and Raphael actually called it an apple, which I think is a pretty good name for it. And let's quickly review how to graph it. We go 9 units down, because 6 plus 3 is 9. 9 down. We will go 6 to the left, 6 to the right. And now 3 minus 6 will be 3 into opposite direction. 1, 2, 3. Maybe 3 is here. And try to graph an apple, and I will use the green color. No, if this is 3, then 6 has to be here. That's a mistake. Sorry, a bit off with the measurement today. Six, okay. And here's the shape of Dimpled Limasson. Well, looks like an apple. All right, so we went over 3 shapes, which we did last time. Limason, Cardioid, Dimpled Limasson. And there are a few more shapes today. We will start with the first, a rose curve. And for this one, I'm going to demonstrate Desmos. I'm going to stop sharing my PowerPoint, and I'm going to share my screen with Desmos. And I would like to demonstrate how the graph of a rose curve look when r equal 5 cosine theta, 5 cosine 3 theta, 5 cosine 5 theta. There should be 7 theta. Basically, the number in front of theta is odd. Odd and even will look slightly different, but first of all, we'll look at the numbers when it's odd. I'm going to, wow, 25 people today. I'm really happy to see you all. Okay, sharing the screen with Desmos. Okay, 5 cosine theta. Can everyone see my screen on Desmos?
Yes.
Thank you.
Yeah.
Thank you. Okay.
Yes, sir.
Thank you. Thank you. Just a quick review. We did this last time. 5 cosine theta, 5 sine theta will produce a circle. But just a quick observation, that's the circle. You go 5 units to the right. The center will be right in the middle. Maybe it's right here, 2.5. And the radius will be also 2.5. Now, how things will change when you will make it 5 cosine of 3 theta. It looks like a rose with 3 petals. That's why it's called a rose curve. Make it 5 theta, and there will be 5 petals. Make it 7 theta, there will be 7 petals, and so forth. Let's also make a quick observation. Let me go back to 3 theta, and let's also notice where all cosine functions start. You see that first petal starts at 0. Would it be true for all cosines? Let's just quickly go over it one more time. Would it be true for 3, for 5, 7, and so forth? It looks like it's true. Can anyone tell me why the first petal starts at 0? It's something to do with trigonometry and when cosine is at maximum. Anyone? Okay, then I'm going to graph this 5 cosine 3 theta back in my PowerPoint and take some notes. And I'm going to explain through trigonometry why the first petal happens at 0. You don't really have to draw it. I'm going to now share my PowerPoint with you. And I'm going to draw it. Maybe I can delete this and draw the picture. All right. So I claim that if I'm going to draw r equal 5 cosine of 3 theta, it has to start at 0. And why does it start at 0? Well, because cosine is maximum at 0. And whenever I'm going to solve an equation of 3 theta equals 0, theta is at 0. Or 5 theta equals 0, theta is still at 0, and so forth. That's why whenever you graph in cosine, whenever you graph in Rose curve for cosine, it will always start at 0. And the length of this petal will be 5 units. Okay, so let's go 5 units. 1, 2, 3, 4, 5. Here's my first petal. Or maybe it should be a bit nicer. What about the other two? How can I figure out the direction of the other two petals? Can anyone help me with that problem? How to identify direction? I know there should be 3 petals, but where they are, at which angle should I graph them? Any ideas? All right, there we'll know there's 3 petals. What is how many degrees is the circle?
360.
There you go, 360. And I know there have to be 3 petals with equal distance between each other. Can we say how many degrees will be between them?
Maybe divide 360 by 3.
There you go. 360 by 3, 120. That's how we figure out what's the difference between the petals. Will be 120. So the next petal, since I started at 0 degrees, the next petal has to be at 120. Well, maybe it's, of course, it's very approximate. It's just a sketch. And I have to go about 5 units as well. I will just try to draw it. No, it's actually smaller. My drawing is not accurate. But the idea that this also has to be 5 units. And 120 plus 120, my third petal will happen at 240. I know this is 180. I know this is 270. Somewhere over here will be my 240. Okay, there you go. The same will hold for 5 theta, 7 theta, and whatever. That will be the approach for odd number. I'm going to pause for 10 seconds and then I will go to make some observations with even numbers. Even numbers act slightly different. There's something to do with symmetry. I'm not doing a formal proof here. We'll just do some observations in decimals. All right, I'm going to stop sharing the screen and share my decimal screen with you. And now let's make observations. What happens when theta is even? So we see cosine of 2 theta produces 4 petals. 6 theta produces, it's hard to count, but I think it's 12, and so forth. Oh, I skipped 4.
Hello, miss.
What is it?
Hello, miss.
Oh, hi.
That's not a thing.
We just observed that whenever it's an even number, the number of petals will double. Again, I'm not doing the formal proof. We just make some observation, and we just learned that such shape exists. If you want to go into more formal proof, I also shared a textbook, a PDF of a textbook, so you can read if you're really interested. Let me go back to my PowerPoint and take some notes. Okay. Let's draw a picture maybe of 2 theta. The approach will be extremely similar. We know there are 4 petals. We know that if you start at 0 because 2 theta equals 0 degrees when theta equals 0. That's when cosine is at maximum. And I know then, since there are 4 petals, I need to figure out the increments when the petals will happen. 360 over 4, 90. Oh, there you go. How convenient. So it will happen at 0 degrees, at 90, at 180, and at 270. And the length of each petal has to be 5. All right, I did my best, but it doesn't look that neat. Let's move on and discuss what happens with the sine. Going to go to this page. If I'm going to graph 5 sine theta, sine 3 theta, and 5 theta, I'm sure you can already make a prediction when it's an odd number of theta, that's how many petals will there be. However, the first petal doesn't start at 0. So let me first of all demonstrate this in Desmos, and then we'll discuss where the first petal should start and how to calculate the increments. Five sine theta. Okay, it starts, let's just notice, it's like one petal. It's a circle, but we can also treat it as one petal. It starts at 90 degrees. That's when sine is at maximum, at 90 degrees. We know sine of 90 is 1, and that's the maximum. Now let's try to graph sine of 3 theta, or sine of 5 theta, or 7, or 9. We can notice that the first petal doesn't start at 0, but where does it start and how to figure this out? Can anyone propose an idea of how to figure out where does the first petal start?
It starts on the y-axis.
Okay, how about the 5 theta? Okay, it's also on the y. How about 7? Also on the y. Anything not on the y? Okay, looks like on the y-axis. Why? But where? On up or down? That's another question. Can I be sure where exactly it starts? So something to do with where sine is at maximum. For example, if I'm going to solve for 3 theta, I know that if it's just theta, theta has to be at maximum at 90 degrees. Well, 3 theta equal 90, theta equal 30, and 30 equal pi over 6. There you go. That's where it is. Or if you would like to figure out where the first petal of 5 theta starts, can anyone predict before I will show it on Desmos where, at which angle will 5 theta start?
90?
How much?
90?
Let's check it out. It will go through 90, but the first petal will happen at, let me annotate. If it's 5 theta equal 90, then theta equal 18. So this first petal will start at 18 degrees. How to then figure out the increments? How to figure out that this will be at 90? I know this is at 18. How do I know where the next one will be? We already did something similar. Don't be shy. We know there are 360 degrees in a circle. This one will have 5 petals. So the increments will be 72. I know the first one started at 18. Second one will be 18 plus 72 equals 90. There you go. Then the next one will be 90 plus 72.
160.
Right, 162. This is 162. Next one will be 162. I can't do this mentally. It's already too much. 234. And the last petal will be 234 plus 72, 60306. And that's the last one. And if I will add 72 more, it will go already more than 360. And that's where I stop. And now I'm going back to my PowerPoint just to take some quick and organized notes about where the sine starts and how to find the location of the petals. Going to stop sharing the screen and I will share my PowerPoint with you. And we'll quickly take the notes of how to graph it. For example, let's do this one. R equals sine 3 theta. Just a quick review that sine is at maximum at 90 degrees, which means we're solving for 3 theta equal 90, theta equal 30. That tells me that the first petal will occur at the angle of 30 degrees. How to find the location of the other petals? Knowing that the circle is 360 and there has to be 3 petals, it will happen every 120. From 30, rotate 120 and you will be at 150. Maybe it's right here. And then from 150, rotate another 120 and you will be at 270. 1, 2, 3. How are we doing so far, guys?
Good.
Still alive? Good.
Good.
Okay. Good, good. Very similar thing will happen when this is even. When 2 theta, 4 theta, 6 theta, when this number is even, the number of petals will be doubled. Now let's maybe grab this one without decimals. Let's do it right away, just knowing what we know already. What do we know? Number of petals equal 4. Where is the first petal? Can anyone tell me where the first one will be?
80?
At 9 degrees.
How much? 90?
45.
45.
45, right. We solved 2 theta equal 90 because sine maximizes at 90 and theta is at 45. That's correct. Thank you very much. If I'm going to graph it, the first petal happens at 45 degrees. And what is the distance between the petals? What's the rotation?
180.
360 over 4. Be careful, there are 4 petals. 90 degrees because there are 4 petals. So the next one will be at 45 plus 90 at 135. Then the next petal will be 135 plus 90, 225. And the fourth one will be 225 plus 90 at 315. And let's draw 4 beautiful petals. Of course, it's a sketch. The length of the petal has to be 5. It's just an approximate sketch of how it could look like. Last one, Lemniscate. I call it graph of infinity. It's not a formal name. It's called Lemniscate, but I'll show you why it's called graph of infinity. I'm going to graph in decimals r squared equal 25 cosine of 2 theta. And decimals doesn't accept r squared, so I'm going to graph as r equals square root of 25 cosine 2 theta. There you go. It does look like infinity. Quick observations. that the length, it looks like a petal as well, maybe I can call it a petal, is root 25, which is 5. Cosine starts maximizes at 0, and there will be 2 petals. Before I will go and make some notes, I'm wondering how r equal root 25 sine 2 theta will look like. Can anyone tell me how will that graph look like? What will be the difference between cosine and sine?
It'll be respective to the y-axis.
All right, let's check this out. Thank you. Oh, it can graph with the second one.
Wouldn't it be slanted, miss, if it was sine?
Yep, that will be slanted. So let me just check it right, change it right here. Yep, that's slanted. By how many degrees?
45.
That's correct. Absolutely correct. Thank you so much. It is 45, and it's something to do when sine is at maximum. We know that sine theta is maximum at 90 degrees. But when you're solving for 2 theta equal 90, you can see theta is 45. That's how we figure out. And because Lemniscate should have the 2 petals, the other one will be in opposite direction. So 45 plus 180 will be 225 degrees. I'm going to go back to PowerPoint, take some quick notes, and that will be it. That will be the end. All right, I'm going to stop sharing the screen and back to PowerPoint to take some notes. Lemniscate, when you're graphing cosine, it looks like a graph of infinity because it does start at 0. The first petal starts at 0, go 5 units on the x-axis, and 5 to the left. 1, 2, 3, 4, 5 to the left. And this is the graph of infinity. I will share all of these notes with you on Google Classroom. So if you didn't have time to write this down, don't worry. I'll share everything with you along with the video. And last one is sine. We know that sine maximizes. Sine theta is maximum at 90 degrees. Well, that was bad. At 90 degrees, solving for 2 theta equal 90, one can quickly get 45. So the first petal will be at 45. The second will be in opposite direction, 45 plus 180 at 225 degrees. And that's it. I'm going to stop sharing. I'm going to stop recording first.